we've started before, we talk about the laws of indices. We talk about the 6 laws, 7 laws of indices. We talk about the multiplication law, which says that a raised to the power of x times a raised to the power of y, which is equal to a raised to the power of x plus y. So as we were saying, a raised to power x times a raised to power y equals to a raised to power x plus y. When you have the same base, the power is added. That is the first law of indices. So example of such is that when you have 3 raised to power 5 times 3 raised to power 1 equals to 3 raised to power 5 plus 1, which is equal to 3 raised to power 6. If I have something like 2 raised to power 6 times 2 raised to power 2, the answer will be 2 raised to power 6 plus 2, which is equal to 2 raised to power 8. That is the first law. Then we go to the second law, which says that that one is called division law. Division laws is that it's just like this. We said if this is multiplication, the powers will be added. So far they having the same base. So in division law, it is let's assume if I have a raised to power x divided by a raised to power y, the answer will be a raised to power x minus y. That is what division law says. Instead of being added here, it will be subtracted here. So that is what division law is saying. So we have example of such is 2 raised to power 4 divided by 2 raised to power 3. So the answer will be 2 raised to power 4 minus 3 will give me 2 raised to power 1. So that is the answer to that. Another example is that if I have 3 raised to power 4, 3 raised to power 4 all over 3 raised to power 2. So the answer is 3 raised to power 4 minus 2, which gives me 3 raised to power 2, which is equal to 9. So that is division law. We go to the other one. We call that one zero power law. Zero power law. Zero power law. What is zero power law saying? So we have x raised to power 0 equals to 1. So we have done this law before in the class that I have with you, but I'm just trying to refresh so that before we go into the real application of this law into different examples. So we have zero power law, that is anything that is raised to power 0 is equals to 1. You see, example is this. So if I have 1,000 raised to 100 raised to power 0 is equal to 1. 1,000 raised to power 0 equals to 1. So if I have 2 raised to power 5 divided by 2 raised to power 5, that means going to give you 2 raised to power 5 minus 5, which is equal to 2 raised to power 0, which is equal to 1. This one can be simplified by saying 2 times 2 times 2 times 2 times 2. This is 1, 2, 3, 4, 5. That's 2 raised to power 5 all over 2 times 2 times 2 times 2 times 2. If you cut, this cancel this, this cancel this, this cancel this, this cancel this, this cancel this. So you have 1, 1, 1, 1, 1. 1 times 1, 1 times 1 times 1 times 1 equals to 1. All over 1 times 1 times 1 times 1 equals to 1. So what we answer will give you still what? 1. Just the way we have it here. So that's why we say anything raised to power 0 is equals to 1. That is the third law. We move on to the fourth law. The fourth law says negative index. It's called negative index. Look at it. X raised to power minus a. X raised to power minus a equals to 1 all over a raised to x raised to power a. X raised to power a. What do I do? This negative sign is what is changed to 1 here all over the positive side of it. So when I have anything negative, I can change it to the positive by putting 1 as my numerator. For example, let's assume I have 2 raised to power minus 1. The answer here will be 1 all over 2 raised to power 1, which is equal to 1 all over 2. If I have 2 raised to power minus 3, so my answer is going to be 1 all over 2 raised to power of 3 equals to 1 all over 8. So anytime you're having negative sign, you can change it to positive. Negative powers rather. Anytime you're having negative power, so you can change it to the positive by putting 1 as your numerator. For example, if I have also this one, if I have something like this, y all over x all raised to the power of minus a. It means that I will say, invariably, what I'm saying is that I will take this one up. This one will be x all over y raised to the power of a. It's still the same thing that is being applicable here. It's still the same thing that is being applicable here. Each and every of this is having a power of a. It's just like saying that this is 1 all over y all over x, everything raised to the power of a. So instead of you do that, this one, by the time you say 1 divided by y all over x, so it will give you 1 all over 1 times x all over y. So that will give you 1 times x, x, 1 times y, y. So don't forget the a that is there. So everything will be a. That's what we have here. X all over y raised to the power of a. Look at it here. X all over y raised to the power of a. So invariably, when you see something like this, you say y all over x into bracket negative a. Just take this up, take this one down. Everything raised to the power of a. So that is what that fourth law was talking about. That is negative index. So it is applicable in so many ways. It is applicable in so many ways. We have it. Let me take some little examples that where it's available. If you have 10 raised to power of minus 2, now it's going to be 1 all over 10 raised to power 2. If I have 1 all over 5, 4 all over 5 rather. Let's say I have 4 over 5 raised to the power of minus 2. So my answer will be 5 all over 4 raised to the power of 2. So which is now going to give me 5 all over 5 is 5 times 5 is 25 all over 4 times 4 is 16. That is the answer to that. So that's how we can apply this. Then we have another law which says, so we have the fifth law. What is the fifth law? It's saying double power law. Double power law. What is double power law? It says that you look at this, x raised to power a bracket b. When you look at this, x is having the power of a. Also, everything there is having the power of b outside. That means it's double. The power is there, double is the power is there. So the answer will be x raised to power ab. You multiply. Don't compare that with this, where we have x a raised to power x, a raised to power y. Multiplication is there. Here, there is no multiplication. So when there is multiplication at the same base, you add. But in this case, when there is no multiplication, it's just double power. You are going to multiply the power. You are not going to add. You are going to multiply the power together. For example, let's take example of that. For example, if I have 2 raised to power 3, 2 raised to power 3 into bracket 2. So I have 2 raised to power 3 times 2. That will give me 2 raised to power 6. I'll take another example just to buttress what we have just done. We have 5 raised to power 2 bracket 2 outside. So that is going to give us 5 raised to power 2 times 2. That's going to be 5 raised to power 4. I hope this is clear. So the next one, we have talked about 5 laws. Now let's go to the other law. We call it fractional index. Fractional index. So far so good. We have talked about 5. I talk about multiplication law. That is one is applicable here. I talk about division law. That is one that is applicable here. I talk about zero power law. That is one that is applicable here. We talk about negative index. That is one that is applicable here. We talk about that is negative index that is applicable all through this place. Then we now talk about double power law, which is here. Double power law is there. Now the sixth one is what we call fractional index. Fractional index. Fractional index. Now let me talk about fractional index. Let's assume we have x raised to power 1 all over a, x raised to power 1 all over a, x raised to power 1 over a. It can be rewritten as this a, that is the denominator, will become the root of that base raised to the power of the numerator. This, I go again, this denominator will become the root of the base raised to the power of the numerator of the index. Now let's take example of such. If I have 16 raised to the power of 2, so my answer will be the root of 16 raised to power 1. This 2 be the root of this. That is the root of 16 raised to power 1. What is the square root of 16? That is 4. Let's take another example. If I have 27 raised to the power of 1 all over, let me say 2 over 3. I don't want to use 1 over 3. Let me say 2 over 3. So I have the third root. It's going to be the third root, that is the cube root. The cube root of 27 raised to the power of 2. What is the cube root of 27? The cube root of 27. So how to get the cube root without even looking at your whatever is just like saying there 3 times 3 times 3. That is what you can multiply in 3 places. That will give you 27. 3 times 3, 9. 9 times 3, 27. Then don't forget the square that is here. So don't throw it away. So we have how many times can 3 go here? That means that I can multiply 3 in 3 places and it give me 27. So that means the third root of 27 is going to be 3. That's the 3 that can use that can give me 27. 3 in 3 places that can give me 27. So I have the 2 here. Don't forget it. That will be 3 raised to power 2. That 3 raised to power 2 means 3 times 3. That is what? 9. So that is fractional index for you. That is fractional index for you. This fractional index can be, let's apply it in another way. Let's apply it in another way. It can happen. Somebody else can apply it in another way by saying 27 raised to power 2 all over 3. So I'll just say how many I'll put this into the power of 3. I'll put it into the power of 3. How will I put it into the power? This one will now be 3 raised to power 3, because 3 in 3 places will give me 27. I'll put it in bracket, then raised to power 2 all over 3. Then I'll have 3 raised to power 3 all over 1 times 2 all over 3. Double power law will come in place now. So then I have 3 cancel 3. Then I have, what will I have left here? This is 3 raised to power 1 times 2. That is 2 all over 1 times 1, 1, which is equal to, this is 2, which is equal to 3 raised to power 2, which is equal to 9. So it's still the same thing the way you solve it here. You are just trying to solve it in another way. So we are the second part, which is applying the laws. Now we are going to apply the laws one by one. We are applying the laws one by one. So we are going to solve indices involving numbers and their powers. So I will take NECO question 2015, number 33. NECO question 2015, NECO 2015, number 33. NECO question 2015, number 33. So what does it say? It says simplify. Simplify. That is 1 all over 4 raised to the power of minus 1 all over 3. Raised to the power of minus 1 all over 3. In this case, they now give us options. They gave us option 1A, minus 1 all over 2, B, 1 all over 4, C, 1 all over 2, D, 2. And E, we have 4. So we have A minus 1 over 2, B 1 over 4, C 1 over 2, D 2, E 4. Let's now solution. So we have 1 all over 4 raised to the power of minus 1 all over 3. There are several ways of solving this. But let's just use one particular way. So I can say this minus, now I change it to positive side. So I come here, I'll say 1 all over 4 bracket. So this one we have 1 on top of it. Why? Why is it 1? Because I've changed, I want to change it to positive side. Raised to the power of 1 over 3. So I have 1 all over 1 all over 4 raised to the power of 1 over 3. So here I have, so this one will come up. It's just like saying, okay, before I do that, let me before I do that, let me just okay, I've told you that this is not 1 over 3, this is 1 over 2. I just discovered that now. It's 1 over 2. So please pardon me for that. That is 1 over 2. So we have 1 over 2 here. So I have 1 all over. So we have the fractional index. The law says that we should say this one is going to be the root of 1 all over 4. If you go back to the video we've done before on fractional index, it says that this one will be the root of this, and it will carry this power. So raised to the power of 1. So this is the one that is carrying as its power. Don't forget, this is the one that is here. The 2 here is the root that you are seeing here. So I have 1 all over, excuse me, 1 all over. The square root of 1 is 1. The square root of 4 is 2. So I have 1 all over 1 over 2. So if I want to get the answer of this answer of this is 1 divided by 1 all over 2, which is equal to 1 all over 1 times 1 over 1 times 2 all over 1, which is equal to 2. So our option is option D. Option D. Option D is the answer. Option D is the answer. So let's take another question. In this one, I'm going to take NAPTEP 2008, number 8. I'm going to take NAPTEP 2008. I'm going to take number 8. So NAPTEP 2008, number 8. So we'll say find the value of 8 raised to power. Find the value of 8 raised to the power of minus 2 over 3. They say they give us the option. The option is A, 1 all over 2, B, 1 over 4, C, 1 over 8, D, 1 all over 16. 1 all over 16. So I'll come here, I'll say this is now, I'll say this is 8 solution. I have 8 raised to the power of minus 2 over 3. Don't forget what we used to do to this negative sign. It's going to be 1 all over 8 raised to the power 2 over 3. So the fractional index law says that when we take this one, it's going to be third root of 8 raised to the power of 2, and that's going to be 1 all over. What is the third root of 8? That is going to give us 2 times 2 times 2. That is 2 in 3 places is what will give you 8. What in 3 places will give you 8? That's what is the meaning of third root. Raised to the power of 2. Don't forget that 2 that is here. So that means the third root of 8 now will be 2. So I have 1 all over, I'll pick 1 here, 2. Raised to the power of 2, which is equals to 1 all over 4. That will be the answer. So our answer is option B. Option B. That's the answer. We'll go to the other one. I want us to take more questions on this before we move to the area of indices, and the next area of indices. The second one the third one I'm going to take from NECO again, 2011. I'm taking from NECO 2011. NECO 2011, number 12. Precisely number 12. I'm talking about objectives. When you see number 12, I'm talking about objectives. We have evaluate 0.008 raised to the power of 1 all over 2. They say give the options are A, 0.15, B, 0.8, C, 0.2, D, 0.5, then E we have 0.1. So okay, from the question is like this is 1 over 3, not 1 over 2. Sorry for that. So we have 0.008 1 over raised to power 1 over 3. So solution now. So it's going to be change this one to fraction to make it easier for you. So I'm going to say change it to fraction. It's going to be 0.008 all over. I'll change it. How do I change this one? Because this point, decimal point become 1. Every other thing follows 0, 0, 0. So what I have here is 8 all over 1000. That's how to change to fraction. So I have 8 all over 1000 raised to the power of 1 all over 3. 1 over 3. So invariably, the fractional index law says that you can solve this in another way, but let me first of all solve it in the fractional index law, which says that you can, what it says is that you can, what it says that you can put this is going to be third root of 8 all over 1000. 1000. This is 1000. Third root of 8 over 1000. What is the third root of 8? That is 2. What is the third root of 1000? That is going to be 10. So my answer is going to be 2 here 1, 2 here 5, which is going to be 1 all over 5. That is option. That's option. That's this 1 over 5 is there. No, that means we are going to get our answer in decimal point. So how many 5 can I find in 0? It's not possible. I have 0 point. If I add 0 to this, making 10. How many 5 can I find in 10? That is 2. Do I have 0.2 there? Yes. Option C. That's option C. That means 3 all over 10 raised to power 3. Everything raised to power 1 over 3. Then I can say, from here I can say 2 all over 10 raised to power 3 times 1 all over 3. So I can't, this one take care of this. What I have here is 2 all over 10, which is equal to 1 over 5, which is equal to 0.2. So that's another way of solving it, depending on the one we want to take. So I'll take the next question, which is NAPTEP again. I'm going to take NAPTEP. I don't know. I didn't have I'll get WAEC question here. Okay, I'll tell you when I get WAEC question, and I'll tell you. Okay, we have NAPTEP again. NAPTEP question. That one is taken from 2008. Number 3. So it's NAPTEP question, November 2008. So it says simplify. Simplify minus 8 raised to the power of 4 over 3. 4 over 3. Minus 8 raised to the power of 4 over 3. You say option is A, minus 32. B, minus 16. C, 16. D, 32. So to solve that, I'll come here, I'll say, I don't need to disturb myself. Solution. I know this denominator is in 3, so I will raise this to the power of 3. So I have minus 2 raised to the power of 3 will give me minus 8. Because I have here, I have note. Minus 2 times minus 2 times minus 2 will give you minus 2 times minus 2 minus plus 4. Plus 4 times minus 2 will give you minus 8. So this is minus 2 raised to power 3. So I have raised to power 3. Then don't forget the bracket, the power that carries it, that 4 over 3. So I come here, I'll say minus 2 raised to power 3 times 4 bracket 3. So 3 take care of this 3. That is gone. Then I have minus 2 raised to the power of 4. What is minus 2 raised to the power of 4? That is minus 2 in 4 places. Minus in 4 places will give you positive. Minus times minus times minus times minus. So minus times minus plus. Plus times minus minus. Minus times minus again. That will be plus. So we have plus. Plus what? 2 in 4 places will give you 16. So my answer here is 16. So do we have 16 there? Yes. C is our answer. C is our answer. Another question. This question says they are WAEC questions and NECO questions. So this one says 4 whole number 1 all over 4. 4 whole number 1 over 4 raised to the power of 6. simplify. So how do we get there? They gave us option A is equals to 1 all over 8, B equals to 4, C equals to 6, D equals to 8. So we have, so to get that, we just do this one. That will be 4 solution. That will be 4 into the bracket of 1 all over 4 times 6. That is double power law. Power is here, power is here. So come here, now is a 4 raised to power. So this one, 1 over 4 times 6 all over 1. 2 here 2, 2 here 3. So what I have left is 4 raised to power 3 all over 2. Fractional index law will now apply. Fractional index law will now apply. So that will be 4 raised to power 3. That will be square root of 4 raised to power 3. Then that will be square root of 64, because 4 raised to power 3 is 64. So what is square root of 64? That is what? 8. So the answer is option D. The answer is option D. Answer is option D. So that's option D. Now we go to the next one. I quickly want to rush the questions because there are a lot of questions I want us to treat. So before now, the next one is simplify. 125 raised to the power of minus 2 over 3 times 15. 125 raised to the power of minus 2 over 3 times 10. So this one is 1 all over 125 raised to the power of 2 over 3 times 15. Then I go on, I'll say 1 all over. So the third root of 125, the third root of 125 raised to the power of 2 times 15. What is the third root of 125? That is what you multiply in 3 places, that will give you 125. So that's 1 all over third root of 5 times 5 times 5. Don't forget the power that is here. So don't always forget that power, times 15. So the third root of 125 is 5. So I have 1 all over 5 square times 15. So that will be 1 all over 25 times 15 all over 1. So that would be 5 here 3, 5 here 5. So the answer is 3 all over 5. 3 all over 5. So that's option B. Sorry, I didn't write the option, but the option is B. So because of time, I want us to cover more questions, so that whenever you see something like this, you'll be able to. This is a WAEC question. The next one is a WAEC question. 125 raised to power 1 over 3 times 49 raised to power 1 over 2 times 10 raised to power minus 1. So I have, what is the option there? Let me click with option A, 1 all over 35, B, 2 over 35, C, 3 whole number 1 all over 2, D 1 over 14, and E 4 whole number 1 over 3. So let's solve it. To solve that, I'm going to come here, I'm going to say 1025, the third root of it raised to the power of 1. Then, because it is 125 raised to the power 1 over 3 here, so I'm going to find the third root of it here and raised to the power of 1 times the square root of 49 raised to the power of 1 times 1 all over 10. So times 1 over 10. So we have the third root of 125 is going to give me 5 raised to the power 1 times 7 raised to the power 1 times 1 all over 10. So what I have here is 5 all over 1 all over 1. So I have 35 all over 10. So 35 all over 10, that's going to give me 3 whole number. It means 5 all over 10. So that's going to give us 3 whole number 1 all over 2. That is option C. Option C. So I'll move on to the next one quickly so that we can cover much. So I have another one which says 1 all over 16 or raised to the power of minus 3 all over 4 divided by 5 bracket 9 raised to the power of 0. Now, so we give options. Is option given? No, option is not given there. I think this is a theory question. This is the first theory question we are dealing with. It's a theory question. I think it's NECO question, and it is 2005 NECO question, and it is 1B of that NECO question, 2005. That's 2005. So I have it here. For me to start, just a solution. Invariably, this is 5, because anything raised to power 0 is what? 1. Anything raised to power 0 is equal to 1. So 5 times 1 is 5. So I'll come here, I'll just say 1 all over, I've inversed this. So this one is 1 over 16, the one that is here, raised to the power of the positive side of it, that is 3 all over what? 4, divided by 5 times 1. So I'll continue. I'll say 1 all over the fourth root. I'll say the fourth root. I'm going to get the fourth root of 1 all over 16 raised to the power of 3. Fourth root of 1 all over 16, just because you have 3 all over 4 here. So I'm going to say fourth root of 1 over 16 is the power of 3 divided by 5, because 5 times 1 is 5. So I'll come here 1 all over. What is the fourth root of 1? Fourth root of 1 is 1. 1 times 1 times 1 times 1 in 4 places is still 1. So what is the fourth root of 16? That is 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, that is 16. That is in 4 places. So 1 over 2. This one will now be raised to the power of 3 divided by 5. So what we have here, 1 all over 8 divided by 5. 1 all over 8 divided by 5. Then I have 8 divided by 5, because this comes up, by the time you say 1 divided by 1 over 8 to be 8 divided by 1. So I have 8 divided by 5. So that's going to give me 8 all over 5. How many 5 will I find in 8? I have 1. It remains what? 3. So that will be, how many 5 will I find in 30? That is 0.6. That's 1.6. So my answer is 1.6. Or you can say 1 will number 3 all over 5. Still the same thing. So this is WAEC question. The next question is WAEC question in 2005. Number 2A. It is a theory question. 2A. When you see 2A, it's a theory question. What does it say? It says evaluate 2 divided by 64 all over 125. 2 divided by 64 all over 125. Everything in bracket raised to the power of minus 2 all over 3. Raised to the power of minus 2 over 3. So to solve that, I'm going to say 2 divided by 64. Now I'll change this to positive 1 all over. This is 2 divided by 2. This big 2 divided by big division divided by 1 all over 64 all over 125. Everything raised to the power of 2 over 3. That is negative index that change to positive here. Then I'll come here and I'll say 2 divided by 1 all over. Fractional index law says that the third root of 64 all over 125, everything raised to the power of 2. So which is equal to, I said 2 divided by 1 all over. So what is the third root? What is the third root of 64? That is 4. That is 4 times 4 times 4 in 3 places. That is 4. So I have, what is the third root of 125? That is 5. 5 times 5, 25 times 5 again, 125. So I have 5 raised to the power of 2. Don't forget the 2. So I have 2 divided by 1 all over What is this? What is this? Square of 4, that's 16. Square of 5, 25. So I have 2 divided by, so this one come up and this one comes down, just as we have been doing it before. That will be 25 all over 16. Then I have 2 divided by 25 all over 16. Then I have 2 all over 1 times 16 all over 25. That is going to give us 32 all over 25. That is the answer. Another WAEC question. That one is 2006. 2006 November. Number 1. Now 2006 1B. 1B. That is GCE. It's a GCE question. November. That is it said without using mathematical tables or calculator, simplify 16 raised to power 1 all over 2 times 8 raised to power minus 4 times 3 raised to power minus 2 over 3 times 81 raised to power minus 2 over 3. Minus 2 over 3. Without using mathematical tables or calculators, simplify this. This is division. Sorry, it's not multiplication. This is division. This is division. This is division. Not multiplication. It's division. This is 81 raised to power minus 2 over 3. This is not just ordinary 2 over 3. It's just minus 2 over 3. This is also minus 2 over 3. So we can go now. So to get this, I want to make sure I split everything back to a kind of indices form. So I'll come here. So this is going to give me 2 raised to power 4. 2 raised to power 4 bracket 1 all over 2. This one 2 is going to give me 2 raised to power 3 bracket minus 4. Then I have times 3 raised to power minus 2 over 3 divided by this 81 will give me 3 raised to power 4 bracket minus 2 over 3. So I will now this one now. This will deal with this. It will be 2 raised to power 4 times half will give me 2 times this 3 times this will give me my 2 raised to power minus 12. 2 raised to power, because this is 3 here, don't forget it's 3 times 3, that's to give you minus 12. Then times 3 raised to power minus 3 times 3 raised to power minus 3 minus 2 over 3, sorry, minus 2 over 3 minus, no, don't let me say minus before now. Let me just first of all divided by 3 raised to power divided by 3 raised to power. This one we deal with it. That will be minus 8 over 3. This 4 times minus 2 over 3. That will give me minus 8 all over 3. Then I come here. This one will now become 2 raised to power 2. The law of this is that when we have multiplication law, we will add the power. So 2 plus, that will be 2 plus minus 12, which is 2 minus 12. If you say 2 plus minus 12, it gives you 2 minus 12. So times the division law says that when we have division, it will be subtracted. That will be 3 raised to power minus 2 over 3 minus 8 all over 3. Then I come here, this one will be 2 raised to power minus 10 times 2 raised to power minus 10 times, then I have this one. It will be minus, this is, I have the same denominator, that will be minus 8 plus minus 8 plus 8. You know why it is plus 8? There is a minus here that I didn't include the other time, so I'm including it now. So I have minus, so minus 2 minus 8. So minus cancel minus to become what? Plus. So I have minus 2 plus 8. Minus 2 plus 8 will give me 6. That will be 3 raised to power 6 all over 3, because minus 2 plus this one will change to plus. Minus 2 plus 8 will give me plus 6. Then I'll take one denominator here. You don't need to find the LCM when you have the same denominator. So I'll take the denominator here. So that is going to be 3 raised to power 6 all over 3. So I have 2 raised to power minus 10 times 3 raised to power 2. So what I have now left is that I have 1 all over 2 raised to power 10. I've changed this to positive times 9. Because 3 raised to power 2, then I have 1 times 9, 9 all over. That's 1 times 9. 1 times 9, 9. So 2 raised to power 10. So what is 2 raised to power 10? That's 10 raised to power 10, 1024. If you say 2 times 2 times 2 times 2 in 10 places, it will give you 1024. That will be your answer. So I have another question which says 9 raised to the power of half times 27 raised to the power of 2 over 3 all over 64 raised to the power of 2 over 3. Options A, 11 whole number 1 over 4. Option B, 1 whole number 3 over 4. Option C, 1 whole number 11 over 16. Option D, 1 whole number 7 over 21. Option E, 1 whole number 13 over 63. So let's work. So the fractional index we affect this, it will be the square root of 9 raised to power 1 times this one will be third root of 27 raised to power 2 all over this one will be third root of 64 raised to power of 2. So what is the square root of 9? 3 times third root of 27 is 3 raised to power 2 all over the third root of 64 is 4 raised to the power of 2. So what we have here is 3 times 9 all over 16, which is equal to 27 all over 16. So that is, how many 16 can I have here? 1. Remainder 9. No. Remainder 11 all over 16. Remainder 11 all over 16. So the option is option C. Option C is the answer. So let's take another one. Let's take another one. That one is 27. Evaluate 27 times 2 raised to power 0 times 3 raised to power minus 2 all over. This one is all over. 27 is not included. 4 raised to power minus 1 all over 2. 4 raised to power minus 1 over 2. So ordinarily this is 0. This is 1, sorry. Anything raised to power 0 is 1. 1 times this one will now be 1 times 1 all over 9 all over 1 all over the root of 4 raised to power 1. 27 times. I expect you to have known that this is, because I'm not doing magic, I expect that to have known that this is 1 all over 3 square, which is 9. That's why I put 1 over 9 all over. Then I expect you to have known that this is also can be 1 all over 4 raised to power half, which is equal to 1 all over the square root of 4 raised to power 1. So that's what I've just done here. So I have 27 times 1 all over 9 all over 1 all over 2. Because what I did was that So this is 1 times 1 over 9 is 1 over 9. So this one is just, so I have here, I have 27 times 1 all over 9 divided by 1 all over 2. So I have 27 times 1 all over 9 times 2 all over 1. So all I have here is 54 all over, because this is 27 all over 1, 27 times 1, 27 times 2, 54, 1 times all over 9. So how many 9 can I find in how many 9 can I find in how many 9 can I find in 54? That is 6. So let's take another question. This says evaluate 2 raised to power 5 times 4 raised to power minus 2 all over 2 raised to power minus 3 times 2 raised to power 0. You are given option. You are given option. This is option A 9, B 8, C 3, D 8 over 9, and E we have 1 all over 4. So this one is going to be 2 raised to power 5. 2 raised to power 5. 2 raised to power 5 times, that will be 2 raised to power 2 bracket minus 2 all over 2 raised to power minus 3 times 2 raised to power 0. So this is 2 raised to power 6, not 0. So this is raised to power 6, 2 raised to power 6. So I have 2 raised to power 5 here times 2 raised to power minus 4 all over 2 raised to power 6, 2 raised to power minus 3 rather, times 2 raised to power 6. So this one, the law of indices tells us that this, when you add this one together, it will be 2 raised to power 1 all over, because 5 plus minus 4 give us 1. So minus 3 plus 6, we go with 2 raised to power minus, this one will be minus, this one will be 3, sorry. This one will be 3, because minus 3 plus 6 will give us 3. Minus 3 plus 6 give us 3 plus 3. So what I have here is 2 raised to power 2 all over, 2 raised to power 1 is 2, 2 raised to power 3 is what? 8. So we have 2 here 1, 2 here 4. So I have 1 all over 4. The option is E. So I'll take the second to the last in this section before we go to the indices in algebraic times and algebraic powers. We're going to take that after this section. So let's finish this section. So we take another one. It says simplify. That is 25 raised to power 2 over 3 divided by 25 raised to power 1 over 6. Everything all over 1 over 5 into the powers of minus 7 all over 6 times 1 all over 5 into the power of 1 all over 6. So I come here. The options are A 25, B 1, C 1 all over 5, D 1 all over 25. So we have, I'll start by solving this. I say the 25, I'll put it in power of 3. So I'll have solution. Let me write solution so that you can know. So we have 5 raised to the power of 3. That's 5 raised to the power of 2 rather. 5 raised to the power of 2. Then raised to the power of 2 over 3. Then divided by 5 raised to the power of 2 again. With the power of 1 all over 6. Then all over, this one will be 1 all over 1 all over 5 raised to the power of 7 over 6 times 1 all over 5 raised to the power of 1 over 6. So in that, when we get to that stage, we start breaking it down. So when we break it down, this one is going to give us 5. This one is going to give us 5 raised to the power of 4 over 3 divided by 5 raised to the power of 2 over 6. 5 raised to, this is 5 raised to the power of 2 over 6 all over 5 . So this is 1 all over 5. I want to go back to this again before I now simplify it. It says 1 all over 5 raised to power minus 7 over 6 times 1 all over 5 raised to the power 1 over 6. Sorry, I'm going back to this. So I'll come back here. That was a 5 raised to power 4 over 3 divided by 5 raised to power 2 over 6 all over 5 raised to power minus 1. 1 over 5 is 1 minus 1 bracket minus 7 all over 6, then times 5 raised to power minus 1 bracket 1 all over 6. So I'll open the bracket in the down part. I'll say 5 raised to power 4 over divided by 5 raised to power 2 over 6. All over this minus cancels minus. I have 5 raised to power 7 all over 6 times then 5 raised to power minus 1 all over 6. Minus 1 all over 6. So the law of indices says that when I have the same base there, the powers. So this is 4 over 3, not 4 over 4. 4 over 3 here, not 4 over 4. So it says the powers will be added together. So I have 5 raised to power 4 over 3 plus 2 over 6. So this thing, 2 over 6 is the same thing as 1 all over 3. I'll change it to 1 over 3. Because by the time I say 2 here, 1, 2 here, that's 1 over 3. All over 5 raised to the power of 7 over 6. 7 over 6 times plus minus 1 over 6. So here the division line, we make this one to be negative, not positive. It's going to be negative. Law of division says that when this is division, it's going to be subtracted. So 4 minus 1 give me 3. So I have 5 raised to power 3 all over 3 here up. Then here is going to be plus because of this multiplication sign here. So I'm going to have 5 raised to power 7 minus 1. I'm going to have 7 minus 1. So that's going to give me 6 all over 6, because 7 minus 1 is equal to 6. So when I add in, so 7, it will be 7 plus minus 1, which is equal to 6. So here you have 5 raised to power 1 all over 5 raised to power 1, which is equal to 1. So the option that is correct, is B. So I'll take the last question on this section. So the last question in this section, it says that root one whole number solution. Root one whole number 9 all over 16. So I will change this to improper fraction. 16 times 1, 16. 16 plus 9, that's 25 all over 16. That's the root. I've changed it to improper fraction. So plus the 32 over 162 raised to the power of half. Now before I raise to the power of half, I can divide this by 2. 2 in 32 will give me 16. 2 in this will give me 81 raised to the power of half. What I did is just I used 2 to divide this, divided by, I have 27 and 64 here, raised to the power of minus 1 over 3. So it will be 1 all over 27 all over 64 raised to the power of 1 over 3. So I come here, I will say this one is going to be 5 all over 4 plus the square root of this, because it's going to be root of 16 all over 81 divided by 1 all over the third root of 27 all over 64, because this one raised to the power of 1. So I have 5 all over 4 plus the square root of 16 is 4 all over 9 divided by 1 all over the third root of 27. The third root of 27 is 3, while the third root of 64 is 4. So I have 5 all over 4 plus 4 over 9 divided by 4 all over 3. What I did was that I brought this one up because of this division line. By the time you divide it, will be because of this division line, this division, not this division line, so that this 4 goes up, the 3 comes down. So we now have 5 all over 4 plus 4 over 9. You first of all treat this division before you treat the addition. Boardman should remember division before addition. So I'll come here times, I'll change this one. This one will now become what? 3 all over 4. 3 all over 4. So 3 here, 1, 3 here, 3. 4 cancel 4. So what I have here is 5 all over 4 plus 1 all over 3. So LCM 12. 4 in 12, that is 3. 3 times 4, 15. Plus 3 in 12, 4. 4 times 1, 4. 15 plus 4, 19 all over 12. That is where we are going to stop on the first aspect of indices. We have not really finished it. It's just one aspect. We are still going to talk about indices in algebraic terms, and indices that is involve simultaneous equation, indices that involve equation, and the likes of them. So I'll do the next video that will be indices in algebraic terms and algebraic powers. Thank you.